Hello everyone, welcome all of you in the lecture of successive differentiation. In today's lecture, we are going to discuss how to calculate nth derivative. As you know, the meaning of successive differentiation, that means we have to continuously differentiate our function. And here, specially we are finding nth derivative. This nth derivative is very important in future examples because we are directly use the nth derivative formulas. So one by one, let's start how to find nth derivative. First of all, I will take one simple example, that is, suppose we have given function y is equals to e raised to power ax plus b, and we know that how to differentiate this function, and first derivative we can find easily. So for nth derivative, we first find the derivative of our given function, that is differentiate with respect to x, and derivative of this term is y1 is equals to derivative of e raised to power ax plus b is e raised to power ax plus b, again derivative of power term. So if we again differentiate this power term, then we get a in multiplication. Now again differentiate this term, differentiate with respect to x, so derivative of y1 is become y2, because we are taking again derivative. So derivative of y is y1, derivative of y1 is y2. If we don't know the meaning of this notation, you see my previous video, so we get why we are writing this y1 y2. Now the derivative of this term is here e raised to power ax plus b, and in multiplication a is a constant, so we can take a outside and then take derivative of this term, and we know that here we have already taken the derivative, and derivative is this one. So the derivative of e raised to power ax plus b is e raised to power ax plus b into a. So therefore here y2 is equals to a square e raised to power ax plus b. Similar way, if we again differentiate this term with respect to x, then we get third derivative of our function y, that is y3 is equals to here y square as it is, and derivative of e raised to power ax plus b is e raised to power ax plus b into a, means again we get a in multiplication. So total is a cube e raised to power ax plus b. Now you have to observe the terms. Here the first derivative y1 we get e raised to power ax plus b into a. In second derivative we get a square into e. In third derivative we get a cube into e. That means if we are continuously doing this process up to nth times, so therefore continuously differentiate this term, differentiate with respect to x up to nth times. Then what will happen? If we are writing y3 then a square, y2 then y2 for a square, then y3 a cube. If we are continuously doing this process up to nth time, then corresponding to y over suffix n, we get a raised to power n e raised to power ax plus b. So this is the nth derivative of e raised to power ax plus b. So here if y equals to e raised to power ax plus b, then the nth derivative, that is y over suffix n, equals to e raised to power ax plus b into a raised to power n. This is our result. Now what is the use of this term? For example, suppose we have given e raised to power 100x plus 90. This is the y equals to function, and we want to differentiate this term 50 times. Then what will be the derivative of this term? So just we have to compare our function with this term, then we get the idea, that is here a is equals to 100, b equals to 90, and we are differentiating this term 50 times, that means n equals to 50. To just put this value in this formula, then we directly get 50th derivative of our function, that is 100 raised to e power 50 into e raised to e power 100x plus 90. In this way we are use the direct formula of our nth derivative. Now this is the one of the example. Now we discuss the next example of finding nth derivative. Another example is y equals to 1 upon ax plus b and find y lower suffix n. That means we have to again find nth derivative for this term. The process will be same. That is, first of all we have to find first derivative of function, that is differentiate this term with respect to x. Then we get y1 is equals to, as you know, if we have given 1 upon x, then derivative of this term is minus 1 upon x square. The same way here 1 upon x plus b, the derivative is minus 1 upon x plus b bracket square into again derivative of this term. So again derivative of this term will be a. Now same way you have to again differentiate the term, differentiate with respect to x, then we get second derivative, that is y2 is equals to, here a and minus 1 is constant, so you may take a and minus 1 outside and then take derivative of 1 upon x square. So the derivative of remaining term is 1 upon ax plus b bracket square, that is minus 2 upon x plus b raised to e power 3. Again derivative of bracket term, we get a in multiplication. That means here minus minus, that means we get 2 times minus symbol, that is minus 1 square into 2 into a square divided by ax plus b raised to e power 3. If we again differentiate this term, differentiate with respect to x. If you are not understanding how I am doing the derivative, just remember the 1 upon x raised to e power n. If we are taking the derivative of this term, then derivative is minus n upon x raised to e power n plus 1. Here x is single, and same way here this bracket term contain single x, that is there is no power of x. That's why we are doing this same process. Therefore again differentiation of this term, so we get y3 is equals to minus 1 square to a square as it is, and 1 upon x plus b bracket cube derivative is minus 3 divided by x plus b raised to e power 4, again derivative of this term, so we get a in multiplication. So we get minus 1 3 times 2 into 3 a cube divided by x plus b raised to e power 4. Now if you observe this term, here we get multiplication, in multiplication 2, then 3, in the next term we will get in multiplication 4. That means this is nothing but the product of 1 into 2 into 3, and this term you may write in the form of factorial, that is it is nothing but 3 factorial. And here whole power is 4. Same way simply 2 we may write in the form of 2 factorial. Now if we take again derivative, that is fourth derivative, then what will happen? It is minus 1 minus 4 into a raised to e power 4 divided by this bracket raised to e power 5. That means total minus symbol is 4 times, and we get 4 factorial a raised to e power 4 divided by x plus b whole raised to e power 5. If you observe now here, if we check this term, then at the time of y1 we get a, or here the power is 2, that means increases by 1. At the time of y2 we get minus 1 square 2 factorial a square, and here again power is increases by 2, means if we compare this lower suffix and power of bracket, then if we are writing 2, then we get 3. If we are writing 1, then we get 2. And in multiplication a, then here we get a square at the time of 3. Then power is, if we are taking third derivative, then we get 3 factorial a cube minus 1 raised to power 3, and lower suffix bracket contain power which is more than, greater than this 3. That is, if we are writing 3, then we get power 4. The same process, if we are repeating up to nth times, then nth derivative become yn is equals to minus 1 raised to power n into a raised to power n into n factorial divided by x plus b raised to power n plus 1. So this is the nth derivative of 1 upon ax plus b. Thank you. Like, share and subscribe.